You've seen the headlines, right? We're constantly bombarded with them. This food causes cancer, or this habit is linked to happiness. But how in the world do we know which of these claims to actually trust? Well, today we're going to climb what I call the ladder of evidence to figure out how to judge these scientific claims for ourselves. Okay, let's just dive right in with a question I think a lot of us have wondered about. Does spending more time on social media actually cause higher anxiety? I mean, it sure feels like there's a connection, doesn't it? We see it all over the news, we hear our friends talking about it. And that right there is the heart of what we're talking about today. Our brains are amazing pattern spotting machines. But the real question, the one every critical thinker has to ask, is this: how do we get from just seeing a connection to proving that one thing truly causes the other? That is a much, much higher bar to clear. So let's start on the very first rung of our ladder. This is where most of those headlines and initial hunches come from. It's called correlational research. And, just like the name suggests, it's all about looking for relationships or correlations. So what is a correlational study exactly? Well, think of it as a form of observational research. Scientists are basically just measuring two different things to see if they seem to move together. The really crucial point here is that they aren't changing anything. They're not messing with the variables. They're just looking. And when they're looking, they're usually searching for one of two kinds of relationships. First, you have a positive correlation. That's when two things move in the same direction. Like, as a person's height increases, their weight also tends to increase. Then you have a negative correlation, which is the exact opposite. As one thing goes up, the other tends to go down. A classic example is school absences. As those go up, grades tend to fall. It's a pretty clear pattern. And this brings us to what might be the single most important concept in all of this. Seriously, if you remember only one thing from our time here today, please make it what's coming up next. And here it is, the big one. Correlation doesn't necessarily imply causation. This idea is absolutely critical. Just because two things seem to be related, that does not, on its own, mean that one is causing the other. This is the big, unavoidable weakness of any correlational study. So why can't we make that leap? Why isn't a connection enough? Well, there are a few big reasons. First, you might have what's called a confounding variable, some hidden third factor that's actually causing both things. So, for example, maybe high stress levels cause both more social media use and higher anxiety. Second, it could just be a total coincidence. Sometimes things just happen to line up by chance. And finally, there's the direction problem. Does more social media cause anxiety, or are people who are already anxious more likely to spend time on social media? See, a correlational study just can't tell you which way the arrow is pointing. So, if we can't prove cause and effect with this kind of research, how do we get any closer to the truth? Well, it's time to climb to the next rung on our ladder. I want you to think of this as a ladder of evidence. Down at the bottom, you have simple observation, where nothing is controlled. But as we move up the ladder, the researcher starts to take more and more control, which gets us closer and closer to being able to say that one thing really does cause another. Right in the middle of our ladder, we find something called quasi-experimental research. Now, this is a huge step up. Researchers here are actively trying to establish cause and effect, but it's missing one key ingredient: random assignment. So instead of randomly putting people into groups, they might use groups that already exist, like comparing students from two different schools. And that brings us all the way to the top of our ladder. This is the most powerful tool we have for figuring out what causes what. This is the gold standard of research, the true experiment. So what makes an experiment true? Well, it really comes down to three key things. First, manipulation. The scientist has to actively change something. Second, a control group. You need a group that doesn't get the treatment, so you have something to compare against. And third, and this is the secret sauce, random assignment. This means every single person in the study has an equal chance of ending up in either the treatment group or the control group. So let's just lay this all out, side by side. You can see that both quasi-experiments and true experiments change variables and use a control group. But look at that last row. That's the real game changer. Only a true experiment uses random assignment, and that single feature is what gives it the unique power to make really strong claims about what's causing what. Okay, so we've climbed all the way to the gold standard, but believe it or not, our work isn't quite done. Even when you're looking at a true experiment, there are a couple more things you need to think about. Let's look at two final ideas for figuring out how trustworthy a study's findings really are. First up, we have something called internal validity. Now, this just asks us a pretty simple question. Can we actually trust the conclusions of this specific study? Was it designed and run well enough to avoid bias? If a study has high internal validity, we can feel pretty confident that the change the researcher made really did cause the result they saw. But then you have its partner, external validity. This asks a totally different but just as important question. Can we apply these findings to other people or out in the real world? A study might be designed perfectly in a lab, but if the situation is too artificial, the results might not mean anything for the rest of us. It's really asking, okay, that's great, but do these findings actually matter outside of the experiment? So, we've gone from just spotting a simple pattern all the way up to the gold standard for proving a cause. And this brings us to a final thought for you. The next time you see a headline making some big scientific claim, what's the very first question that's going to pop into your head? Was it just a correlation they found, or did they actually run an experiment? Knowing that difference, that's your first and most powerful step to becoming a smarter consumer of information.